So what I'm trying to do is build a picture that demand for infrastructure, transport infrastructure, is derived from the demand for agricultural products, which is determined by all of these other factors. So we need to explicitly draw out these linkages in our planning if we are to effectively integrate agriculture within the infrastructure planning approach. It's not good enough just to simply say, well, agriculture is going to grow, therefore the volume's going to grow, and therefore we can think about things in the sort of traditional way that we always have, just in terms of volume, tonnes, kilometres. I think to plan in a more sophisticated way, we need to start to pull apart some of these drivers. If we did a quick review of all the various forecasts that people have done, this graph just sort of shows the variance along some of those forecasts. So the 100 line is the projection in 2050 for a particular outcome, and then the variance up and down is just designed to show the percentage variance in the range of forecasts that come out. Now, unfortunately, this chart's distorted a little bit because there's wild variations in what people are projecting about the volume of grain that might be used for biofuel demand all over the place, which is interesting. So that tends to distort the other lines, but if you look carefully at them, you see that all the various factors have reasonably significant variation around them. Probably one of the most certain factors is global and Australian population. That's because demographics has a certain inertia built into it. Once you've got a particular age structure of a population and a few things to do with fertility rates, that pretty well locks in population growth for the next 20 or 30 years. But other things like agricultural prices with biofuels, Australian grain exports with biofuels, climate change itself, salinity, you can see these are highly variable. The forecasts are highly variable. So the proposition that we would put then is it would be a mistake to base infrastructure planning on forecasts, because you can see it really matters which particular forecast you take. It's much more effective, we think, and much more appropriate to construct a range of scenarios based on drivers that we understand, and then to use robust decision making around those scenarios. So I'll illustrate what I mean by that. Here's some illustrative scenarios that we put together. There's a lot more detail in the report. Along the top there are our short names for the scenarios, hopefully fairly logical. SDLs just refers to the sustainable diversion limits under the Murray-Darling Basin Plan. Bit of a hard thing to talk about right at the moment, given that most of the Murray-Darling Basin's underwater. Water shortages, climate change, big Australia, productivity advances, global food crisis. What the different cells in this table show is just how you can vary settings to construct a range of scenarios. So in the SDL scenario, the key thing we focus on is water availability in the Murray-Darling Plan. How much will production change in the irrigated regions as a consequence of that plan? In the water shortages, we imagine a scenario where the future looks something like the last 10 years, but 2, right? So the drought. In the climate change scenario, we hold everything else constant except for the particular climate change variables. Now, obviously, there's a lot of them, so I don't have time to go through all the details, but this is just to illustrate how we go about constructing these scenarios. There's a big Australia scenario, so imagine we have very high population growth in Australia. You remember not that long ago, there was a lot of discussion in Australia about, do we have a population policy? Do we go for a big Australia or a small Australia or whatever? That will have an impact on agriculture. Productivity scenarios, we can look at high or low future productivity scenarios where what we're focusing on is the productivity aspect and holding everything else constant. And then the one I've called global food crisis is where we put a number of in this case, negative elements together. So we have high global population growth, we have low water availability in Australia, we have other aspects of climate change happening, and then possibly we have a biofuels policy kicking in as well. So countries are keen to do something about carbon emissions, and so at the same time as high demands for food, we also have high demands for agricultural product for biofuels reasons. So you can set up a range of different scenarios, and the whole point about setting up a range of scenarios is just that. You set up a range rather than rely on one or two forecasts. Now, what often happens is when you go through your range of scenarios and look at the outcomes, you can see some outcomes are more common than others. And you can see a pathway through constructing what's known as robust decisions. Not necessarily the optimal decisions, but decisions that are robust to a range of different scenarios. And that gives you your minimum starting point for your planning and your infrastructure planning. So here I've constructed it a little bit artificially just so that you can see the way in which some of these common elements might emerge. So it's the same along the top there, the same scenarios, and in the rows we're looking at volumes, export shares, commodity mix, and location, for example. Now, if you think of in the SDL scenario, if we at least take one end of that, volume produced may go down. It's likely that as a consequence, average export shares will go down, and with higher values of water, the commodity mix will tend to shift towards higher value commodities, which are some of the more valuable commodities in horticulture and so on. Similarly, with water shortages, you get decreases in volumes produced, possibly decreased export shares, possibly a shift away from cereals and grain crops to other sorts of crops, and possibly a shift in location to northern agriculture. Climate change, similar sorts of stories. With a big Australia, volumes produced may increase, but the export share may go down again. With productivity advances, you may get both volume increases and export share increases. What it does to the commodity mix depends entirely upon how the productivity is coming about. And in a global food crisis scenario, mixed with a strong biofuels policy, we may have decrease in volume for agricultural production, decrease in export share, and a change in the commodity mix, possibly towards grains and oilseeds, again depending upon what happens in the biofuels. The point of this is to show that the pale blue, I presume it's blue, text shows that there are some common elements. All right, now this is a simplistic presentation of it. A real scenario analysis has quite a bit more in it, but you can sort of pull out some common elements here. One of them is, well, changes in the export share, right? Possibly a greater focus on being able to get product into the urban fringe, into the urban areas and into cities, for example. And a common theme of changes in the commodity mix, maybe away from some of the bulk commodities that we're used to towards some different commodities. That gives us sort of a bit of a picture of the idea we're trying to suggest about robust planning within infrastructure. What needs to be done? There's clearly a number of research tasks, and I think this is where there's enormous opportunity for the agricultural sector to inject ideas into the broader planning that takes place in government. First one's on data collection. I've already said there's a lot of work going on there, but I think the ag sector needs to take a bit of overview on that because, as you all know, agricultural data collections in this country are generally very poor, particularly for the non-bulk commodities. So some focus there. Constructing some sensible scenarios around the medium to long term. So we've got a few suggestions in this report. It's possible to go a lot further than that and construct many, many more scenarios. Obviously, this has to be linked with really, really careful spatial analysis because ultimately the transport task is related to spatial distribution of production and consumption. And the final step is to link those spatial agricultural forecasts and scenarios to logistic and transport models. Now, this is something that's within the expertise of the department, particularly the Bureau of Transport Economics. And there's a lot of interest there in actually sensibly combining agricultural forecasts with these sensible logistical models. So there's a big opportunity at the moment to really inject some of the ideas from agriculture into this broader planning. Thank you very much.